A robot just moonwalked on a soccer field. Another one is closing in on Usain Bolt's world record. And scientists grew living muscle, stuffed it inside a machine, and it swam faster than anything like it has ever moved. This is not a concept video. This happened last week. Let's start in South Korea, because CAS just dropped something that looks genuinely different. Their Humanoid V0.7 ran across a soccer pitch. It jumped, it took shots on goal, and then it threw in a moonwalk. Mid-demo, like it was nothing. Most humanoid videos still feel slow and stiff. This one looked fast, balanced, and confident. But here's where it gets interesting. The team built everything themselves. The motors, the gearboxes, the drivers, every core component. This is not a flashy shell around someone else's parts. They own the full system. The robot weighs 165 pounds. It stands around 5'5", and it can already run at 12 kilometers per hour. The knee actuator alone hits 320 Newton meters of peak torque. They trained it with deep reinforcement learning mixed with real human motion data. That's why it moves the way it does. The next goal is 14 kilometers per hour, ladder climbing, and steps over 40 centimeters. This is just version 0.7. That's the part that should get your attention. Now let's switch gears completely, because Cranfield University built a robot that does not use a battery to move at all. It runs on wind. And before you think that sounds simple, here's why it actually matters. Movement alone burns through about 20% of a robot's battery. In long missions across deserts, polar regions, or other planets, that becomes a hard limit. Wanderbot solves that problem. It is fully 3D printed, modular, built around a wind turbine and a multi-legged walking mechanism. If a part breaks in the field, you print a replacement on site. No resupply, no waiting. It already got attention at the European Space Agency's conference this year, and the team is now focused on one thing: teaching it to turn. That's the next wall. A robot that could one day walk across another planet on its own, and the current challenge is turning. That tells you exactly where this technology is right now. But not every robot story this week was inspiring. A service robot at a hot pot restaurant in China started its dance performance. And then it swung its arms, smashed plates, sent chopsticks flying across the room. Staff rushed in to physically shut it down before someone got seriously hurt. One employee was on her phone mid-chaos, likely trying to shut it down remotely. The robot is believed to be an Agibot X2, the same model shown at CES 2026 earlier this year. Now, here's the part that made this dangerous. This was a hot pot restaurant. There were pots of boiling soup sitting right on those tables. If the robot had knocked those over, we are not talking about broken dishes anymore. The operator said the robot didn't malfunction. That it was brought too close to the table at a guest's request, maybe that's true. But this is not even the scary part. Robots that perform perfectly in controlled demos can become a serious hazard the moment the real world gets unpredictable. And the real world is always unpredictable. Now this is where things change. A team in China built a system called Layton that teaches a humanoid to play tennis using imperfect amateur motion data. About 5 hours of motion capture from non-professional players, that's it. They broke tennis down into smaller chunks. Forehands, backhands, footwork patterns. Then use reinforcement learning to teach the robot to react to real incoming balls. They deployed it on a Unitree G1 humanoid. They ran 10,000 real-world trials. Peak success rate, 96.5%. Let that sink in. Multi-shot rallies with actual humans from both sides of the court. The researchers say this same approach could scale to soccer, parkour, and beyond. Robots learning fast, dynamic sports from messy human data. That's the real breakthrough. And while that's happening, China is also chasing raw speed. Unitree's founder made a claim that sounds almost impossible. He said humanoid robots may soon beat Usain Bolt's sprint record. That sounds crazy until you check the numbers. A full-size humanoid called Bolt hit 10 meters per second earlier this year. Usain Bolt's world record averaged 10.44. The gap is no longer massive. The claim is that by around mid-year, a humanoid could run 100 meters in under 10 seconds. Even the people making that claim admit the hardest part is not speed. It's what happens when conditions change. Robots that run beautifully in a controlled setting can fall apart the moment the world becomes unpredictable. That is still the hardest wall in this entire field. Now here's the part nobody expected. Researchers in Singapore built a fish-shaped robot called Ostrobot, powered by living lab-grown muscle tissue. And here's the wild part. The muscles trained themselves. Two engineered tissues were connected so they naturally pull against each other as they develop. No external training, no outside force. The muscles just exercise themselves. What came out of that process was a robot that hit 467 millimeters per minute, the fastest ever recorded for a skeletal muscle-driven robot. It swims more than 3 times faster than versions built with standard tissue. Researchers could control it with electrical signals. They could even make it start and stop by clapping. Biohybrid robots used to feel more like curiosity projects than real technology. This one is starting to feel like something else entirely. And this is where it gets even crazier. Because while labs are pushing biology and speed, the business side of this race just shifted into a completely different gear. UB signed a deal with Siemens to push humanoid manufacturing toward 10,000 units per year by 2026. Total humanoid robot orders reportedly topped 1.4 billion yuan in 2025 alone. Siemens brings in the industrial infrastructure, simulation, product design, process planning, manufacturing management. Because building one impressive robot for a demo is one kind of achievement, building thousands of them reliably, affordably, and at high quality is a completely different challenge. The real shift is happening right now. That's when humanoids stop being a viral clip and start becoming an actual industry. Meanwhile, Oklahoma State University is working on something that sounds almost like science fiction. A robot that reads human brain signals to catch mistakes before they happen. The system uses an EEG cap to detect a signal the brain produces the instant a person realizes something has gone wrong, often before the body has even physically reacted. Once detected, the robot slows down, stops, or returns control within milliseconds, designed for high-stakes environments. Nuclear cleanup, deep-sea operations, places where a single small mistake can turn into catastrophic damage fast. But here's where it gets interesting. The same technology could eventually power prosthetics and exoskeletons that respond directly to what a user intends, not what they manage to physically signal. The line between human and machine control is starting to blur, and nobody predicted it would happen this fast. But speed isn't the only race. At scale, robotics is going to create a serious waste problem. A research team across 3 universities decided to solve it early. They built what they describe as the first fully compostable soft robot with real durability. The actuator held up through 1 million cycles. The electronics are biodegradable. Under industrial composting conditions, the whole system broke down in a few months. Zero toxic residue. Plant tests confirmed the compost was safe to use. All of that packed into a single robotic finger that also carries sensors for temperature, touch, strain, humidity, and even drug delivery. Not a toy eco-demo. A serious attempt to solve a problem most people in robotics are not even thinking about yet. And finally, hands. Because hands have always been one of the hardest problems in all of robotics. South Korean company Tasalo just introduced a 5-finger robotic hand with 20 degrees of freedom. It measures 21 centimeters. It weighs under 900 grams. Back-drivable joints help it absorb impact and interact more safely with objects. Samsung is building its own hand lab, chasing designs that can detect pressure, texture, and tiny slips the way human hands do. The global market for humanoid 5-finger hands is projected to hit $876 million by 2030. The hand problem is finally getting the attention it deserves. And all of this happened in just days. 1 week. A moonwalking humanoid, a wind-powered explorer, a living muscle robot, machines reading your brain, and an industry quietly gearing up to build all of this at scale. This isn't the future anymore, it's already here. And the scary part? This was just 1 week. Now imagine what happens next.